on this and have had the privilege of being on this discussion site. I've known Mehmet for a long time, and he knows that about my commitment to try to bring Muslim and Christian philosophers closer together. We have lots of areas of mutual interest. And I think one of the people that's one of the most obvious people to bring across the bridge from Christian to Muslim philosophy is Rob Koons. Rob works in areas of philosophy of religion that I think a lot of Muslims would be interested in. He has an interest in Thomism, which I think a lot of Muslims would be interested in, probably in part because Thomas was deeply influenced by Muslim thinkers. He has an Aristotelian way of thinking about things, which I think lots of Muslims would be interested in. So I think it's great that Rob agreed to be the 100th participant in this discussion. I do have one thing to say about Rob, but it's nearly completely non-informational. Rob and I were undergraduate students together. And we found this out way long after we graduated. We were undergraduate students and we never met each other the whole time. And I think it's interesting, Rob, that two of Michigan State's undergraduates from 1978 would go on to be fairly well-known Christian philosophers because, as Rob can tell you, I think there were 0 Christian philosophers in the department at the time. In fact, I think there were a lot of anti-Christian philosophers in the department at the time. Yeah. And maybe Rob was interested in philosophy for some of the reasons I was, and that is that that you wanted to kind of take on secular academia. And Rob has been a champion of taking on secular academia for as long as I've known him. He teaches at the University of Texas, and I think the University of Texas Philosophy Department is probably pretty close in spirit to the Michigan State Department. They're pretty hostile to theism and probably especially to Christianity. And Rob has risen to the challenge and produced, I think, some of the best philosophy of religion and some of the best Christian philosophy and some of the most well-developed analytic philosophy of religion of the past 20 or 30 years. So it's an honor to have you on here, Rob. I will turn it over to you.
Thank you, Kelly. It's very, very kind and generous introduction. Appreciate that. Actually, I have to say the department, although I think you're right, the department here is not exactly friendly to theism. They've treated me really well. I can't complain at all over the years. So it's been a good place to be. And I'm very honored to be part of this. And like Kelly, I'm very interested in building bridges across this Christian-Muslim divide. And recently actually been more especially interested in Ibn Sina, the great Muslim philosopher. I've been working through some of his ideas right now. Again, as looking at how he influenced Thomas Aquinas, which Billy alluded to. So today I'm going to talk about something a bit different from that. Be happy to talk about more about that during discussion time if you'd like. But I was going to talk about some of the work I've done on the relationship between ancient metaphysics, Aristotle's metaphysics in particular, and contemporary science, especially the quantum revolution. And I'm especially interested in how that quantum revolution works its way out in chemistry and thermodynamics and some of the other called special sciences, which are not, well, I think very important myself, crucially important. So this talk's going to be a bit of a mixture, probably mostly philosophy, and then I'll dip into some very little bit of quantum physics in section 4. So let me go ahead and, if you don't mind, share my screen and let's see here. I should know how to do this better, but I'm still a little awkward. I think that will work. Is that working? There we go.
Not yet.
Okay, let me do that. How about that?
That, perfect.
Okay, very good. And let me go back to the beginning here. Great. Good, very good. So, yeah, how quantum revolution vindicates Aristotle's metaphysics. So I've been interested in Aristotle for a long time. When I was in grad school, I remember at UCLA, one of my teachers, Robert Adams, was very positive about how important Aristotle's theory was. And he said, unfortunately, it's all scientifically obsolete. We can't believe any of it anymore because of the scientific revolution. And I thought, well, that's too bad. And what I found over my project for the last 8 or 10 years is to argue that actually that's wrong. It may have seemed that way at the time of the 17th century scientific revolution, but with the quantum revolution of the 20th century, I argue that in fact, Aristotle's ideas have been vindicated and should be taken much more seriously now than they have in the past. So this is a project that I've started and I've been attracting some new people to be part of it. William Simpson, I'll mention him, is a young philosopher of physics who is working with me on this, and we're gradually accumulating more collaborators over time. So just a quick overview. I want to talk a little bit about what substances are and why we need to have them, including substances in the inorganic world. Then a little dip into physics, why I think quantum particles can't be substances in Aristotle's sense.
Hey, Rob,
yeah.
Can you make your presentation full screen?
Okay, yeah, let me see.
Maybe F5 or
how about that?
There we go. Perfect.
Is that better?
Yeah. Off and on.
Why is it not moving? Let's see. There we go. Okay, I got it now.
Yeah.
Great. So again, back into metaphysics a little bit. What are substantial forms? Because for Aristotle to have substances, you have to have things called forms. I'll explain those a bit. And then finally get into physics in section 4. And then in 5, explain how I think we can map some of these philosophical ideas into contemporary science fruitfully. So again, I'm going to talk a little bit here about what substances are and sort of locate Aristotle's view about substances in current debate about what's fundamental in the world, whether it's the microphysical things, whether it's the microphysical things plus some emergent things, or Aristotle's answer, which is no, it's the composite substances that are fundamental. And then conclude that section with a little bit about what the world's substances then are if they're not quantum particles. Okay, there we go. Okay, so what is it to be a substance? The Greek word here is ousia, and it means there's sort of 4 characteristics, I think, that Aristotle's substances have. First of all, they're the things that exist in the most central focal sense of the word, at least that creatures are capable of. God exists in the truest, most focal sense, but insofar as creatures can exist, substances are the most existing, the things that exist in the most perfect way. They constitute the uniquely fundamental level of created reality. So again, within creation, you have substances that are most fundamental in describing things. Each substance has per se unity. So substances aren't just heaps of things, they're deeply one in some sense. And they're the ground, the basis, the foundation within nature of all change and persistence. So ultimately everything in science really turns on these substances and the way they interact with each other. So in the modern world, modern Western world, the last few hundred years, there's been a movement back towards ancient atomism in many ways. And the form that takes is the idea that it's the microscopic things, whether it's particles or bits of matter that are point-sized or fields, values of fields at points or something like that, something very, very small, which are the fundamental things of the world. And everything else just is a consequence in a very, not causally a consequence, but it's just a byproduct, just a way of looking at those microphysical things with a kind of blurry vision, right? And that's the only kind of reality that large scale things like us have, right? And of course, what this does, I think, is it puts human agency our ability to act as free agents, and also our knowledge of the world, human epistemology, under real threat, because it looks as though, what's really going on in my life is my particles moving around according to some microphysical law. And so my choices are not making any difference to the world. And nor are my judgments or my intuitions. They're not really making any difference. It's the particles that are in control, the particles that are making things happen. And so I become a second-class citizen, so to speak, in the metaphysics of the world. Now, this fact results in some extreme reactions within the modern world. Descartes himself, on one hand, René Descartes, pushed this kind of microphysicalism, that what really determines things is what's going on at the material level at a very small scale. But then he tried to save human agency and human knowledge by being a dualist, by introducing a whole separate realm of substances that were minds. And this, of course, creates all kinds of problems about how these minds are going to interact with the physical world. And others go even more extreme views. There are people who are idealists who basically deny that the scientific description of the physical world is ultimately real at all. That's all that's real are the minds, and everything in the science is merely an appearance. So those, I think, are problematic responses, I think. And so we've got, in a way, three options here: microphysicalism, no human agency or thought, dualism or idealism. Dualism has this problem of how to have interaction between these two realms. The idealist has to throw science away in some sense. So none of those seem to be really satisfying responses. Another response that contemporary philosophers have proposed is what's called emergence. And here I'm talking about what's called strong emergence. So in addition to all the microscopic things, there are some fundamental entities that are macroscopic, but still material. So they're not Cartesian minds or souls. They're like you and me, organisms, perhaps. Peter van Inwagen and Tim O'Connor have this kind of view. So the world is made up of fundamental particles and fundamentally real organisms. And those organisms have some new powers, right, that are over and above what's going on at the microphysical level. So there's two problems with this. One problem is that it seems to lead to a kind of overdetermination here, because all my particles are fundamentally real, and I'm fundamentally real, even though I'm made up of those particles. There seems to be a kind of double counting going on here, right? I mean, there's more fundamental real things in this same place than there's really room for in a good account. And in particular, the second problem is when you really start to figure out, how am I going to make a difference as an emergent entity? I still have Cartesian-like problems, right? It looks as though I've got to interact with my particles and make them move around in certain ways. And so although it's supposed to be non-dualistic, these emergent things are supposed to be physical things, still they end up having to interact with microscopic physical things. And it ends up kind of a messy picture, a picture that's hard to reconcile. So the Aristotle's answer is basically to say that there are indeed composite macroscopic substances like you and me and other organisms. And those substances have parts, but those parts are not fundamentally real. They're not fundamental entities. The parts depend on the whole, not the other way around. So that's the crucial idea, a kind of holism that is unique, I think, to Aristotle's picture. In particular, you get two kinds of parts in Aristotle's view. You get what I call integral parts, and you get potential parts. And there's some things that are both, it turns out, but roughly speaking, we can divide it into these two. So an integral part would be something like my hand or my heart or my eye. Those are integral parts of me. They're certainly actually there, right? I mean, my hand is here all the time that I am. It doesn't sort of pop in and out of existence in any sense. It's actually there, but it depends upon me in the sense that you can't really get a human hand, Aristotle would say, except when it develops as part of a human being. You can't have a human hand just kind of floating around on its own apart from human beings. And that's part of the reason that is the very definition of a human hand or a human heart or a human cell, part of the very definition of what it is to be that sort of thing is that it's part of a human being. So they have a deep dependency of the part upon the whole in that particular case. The other kinds of parts are potential parts, or we might call them even stronger, a virtual part, right? So a virtual part is something that's a material part of a material substance. So here what I have in mind are something like the electrons, protons, neutrons, atoms in my body, right? They're material, I'm material. They're a part of me, but they only exist potentially, at least most of the time, they only exist potentially. So the electrons, protons, neutrons that make up my body don't exist in the realm of actuality, but almost always in the state of potentiality. They have the potential to exist when something interacts with me in a particular way. You can make me express myself electronically, so to speak. And when you do that, some electron in my body is actualized. But before that interaction happens, the quantum particle exists only potentially. It isn't actually there. This is a pretty radical idea, right? Aristotle often says that to exist, is said in many ways. There are many different ways of existing. And a very important distinction is between existing actually, which is what substances do, and existing only potentially, which is what virtual parts of substances do in this particular case. So you can see how this might be relevant to quantum mechanics, right? Because on some interpretations of quantum mechanics, right, the whole quantum world exists only potentially until it's observed by some human being. This was a very common view from the Copenhagen period. John von Neumann and others thought this. And of course, Einstein rejected this and said, look, the consequence of that view is that the moon isn't there unless somebody's observing it. And that seems pretty crazy. And I agree that it would be crazy, right? But what I do think is that the particles of the moon wouldn't exist unless somebody were observing them, right? So I make a distinction between the moon, which is maybe one of the substances or made up of substances on the one hand, which really is actually there independent of being observed. And it's quantum particles, which actually aren't there unless, well, they don't have to be observed, but they have to interact with something macroscopic. So ordinarily they exist in a realm merely of potentiality on this kind of picture. Okay, so let's see if I can get the next page. Yeah, so here's just a table to kind of clarify or to classify a number of different parts, because you can actually have, as I said, you can have parts that are both actual and integral, obviously. What you can't have, and notice none over here on the right, what you can't have on Aristotle's picture is a part that's both actual and not integral or definitionally independent of the substance. Because this right-hand upper quadrant, that would be parts that are completely independent of the substance. And for Aristotle, there's no such thing, right? Parts have to be dependent on the substance. So one way to be dependent is to be integral. And another way to dependent is to be virtual. Whoops, sorry. You'll notice I have particles and atoms showing up in two different cells here on the left-hand side. So most of the time, the particles and atoms and molecules in my body are merely virtual or potential parts. But when they're activated by an interaction between me and something else, they move up to the level of being actual integral parts of me, as opposed to merely virtual parts. Okay, so what are this world substances? I've used over and over again already organisms like you and me and other animals and plants as examples of substances. And for Aristotle, those are paradigm substances to be a living organism. But the world consists of lots more stuff than just living organisms, right? And more than just living organisms and their various bits and pieces, even remnants and so on. There's a vast, huge inorganic world out there. And for Aristotle, substances are the fundamental level of reality. So something like a tiling constraint comes in here, right? Just as a floor to be completed, it has to have tiles over every space. So in the same way, for the universe to be a universe, it has to have substances all over the place, right? To be the foundation of reality. And so there have to be substances out there in the inorganic world too, right? Not just in organisms. But what are they like, these substances, these inorganic substances? Well, this is section 2 now of the talk. I want to say they're not quantum particles. So the electrons, atoms, protons, and so on out there, photons, those are not substances, I think. And for a number of reasons having to do with some of the scientific details. One is that these quantum particles have a kind of lack of individual identity, typically. And this shows up in the way that our statistics works as we analyze these particles. So in classical mechanics, classical statistics, if you have two particles, they have two definite identities. And if there's two states like up or down, then there's 4 possibilities, right? A up, B up, A down, B up, down, A up, B down, A down, B up, right? All 4 possibilities are equally possible, right? And typically they each get the same probability, 1 quarter, 1 quarter, 1 quarter, 1 quarter. In quantum theory, you get 2 different kinds of statistics. You don't get classical statistics anymore. You get Bose-Einstein statistics and also the Fermi-Dirac ones. So I'll just talk about the Bose-Einstein ones right now. In this case, you just have 3 possibilities, both up, both down, 1 up, 1 down. You don't get a distinction between which one's up and which one's down. And that reflects the fact that in quantum mechanics, these particles lack individual identity, right? They're just one of a crowd, so to speak, right? They aren't identifiable as individuals. Whereas substances, since they're fundamentally real, right? And they have per se unity, substances have to have their own identity. And so quantum particles seem to be disqualified from that point of view. The number of particles in quantum field theory is something that depends on your frame of reference. So depending on how fast you're moving, if you look at a particular region of space, you may either see a vacuum where there's no particles, or you'll see a situation where there's multiple particles that have been actualized. Again, whether a substance exists or doesn't exist should be a fundamental fact of reality. It shouldn't be dependent on your frame of reference for Aristotle. So that's another reason to think that particles can't be substances. And of course, particles typically lack definite boundaries and definite trajectories. You can't often say where the particle is with any determination. But again, substances should have a full complement of fundamental properties. So those are some of the reasons. We could talk more about that, but those are some of the reasons why I think particles are not good candidates for substances. All right, so now I want to talk a little bit about substantial form. So Aristotle talks a lot about form. Greek word is typically eidos, sometimes morphe. And Aristotle's notion of form is derived from Plato's theories of the forms, which are also sometimes called eidos, sometimes idea, ideas. So to get a quick summary or reminder of what Plato's theory of forms are like, you've got a kind of world of Platonic objects above, the form of the good, the form of justice, the form of the cat, and so on. And then down below, you have the individual or particular objects that instantiate these forms, that the forms inform in some way. And what Aristotle does is he immanentizes the forms. That is, instead of having a separate realm in which these forms exist, he brings them down to earth, so to speak, makes forms part of individual things. So in fact, there are multiple forms of humanity, one for each human being. But nonetheless, these forms, even though they're individual, they still continue to, for Aristotle, play a role in explaining the similarity of things within a species. We could talk more about that during discussion time, how that works. I've got some ideas about that. So forms for Aristotle, not external to a substance. So there's no sort of strange action at a distance. And these forms also provide Aristotle with an explanation for things like species, genera, differentia, and so on, which you see in biology, but also see in physics, actually, right? Particles belong to species, which belong to larger genera, and so on. So all that can be explained in Aristotle's terms. Okay, so now we're ready to talk about a little bit more about quantum mechanics and get into some of the nitty gritty. And before I do that, I'm going to make a little distinction here between token and type substances. And then we'll get into some of the nitty-gritty of quantum theory, algebraic quantum theory, and thermodynamics and chemistry, which are the sorts of things I'm interested in. So again, we need to distinguish here between tokens and types in Aristotle. This is already in the categories. So a token substance is a particular substance like Socrates or Bucephalus, Alexander's horse, or a particular drop of water or the sun. And then there are substance types, species like human being, horse, water, granite, and so on. And so I'm going to be talking really almost entirely about token substances. I'm not going to really worry at this talk about substance types much. So let's try to focus on that. We want to talk about token substances. So individual organisms, raindrops, icebergs, and so on, not the type like mammal or water or alloy or what have you. And it doesn't actually matter whether the token is an artificial token or a natural one on this view. So false teeth, swimming pools, ice sculptures, nuclear reactor cores as particular things. I think these are all plausible candidates of substances for Aristotle, even though they've been produced by human beings. On the other hand, if I have an artifact which is composite of which has been sort of stuck together like a chair or a table, those typically aren't substances on Aristotle's view. So whether something's a substance or not is independent of whether it's been created by human beings or whether it's natural, but it has rather to do something with the internal constitution, the way the thing has been put together. That's what's going to matter for Aristotle in the end. Okay, so on my view, a chemical substance, a token chemical substance, like a drop of water, I think, is a body of matter that has thermodynamic, and chemical properties fundamentally, sort of irreducibly, right? And this is the point I'm going to make, is that individual atoms and even molecules and particles are not chemical substances because they lack these thermodynamic, chemical and thermal properties. They don't, an individual electron doesn't really have a temperature. It doesn't have, you can't really talk about its entropy. You can't talk about its chemical properties. Only chemical substances have those sorts of properties. And organisms, and these chemical substances have quantum particles and atoms and molecules, but they have them typically as virtual parts rather than actual parts. So the parts of the whole substance, the quantum parts, depend upon the whole. Right? So in effect, what I'm doing here is suggesting an inversion of the usual relationship. Ordinarily, we think of chemistry as being dependent on like particle physics. And I'm suggesting it's actually the opposite. Chemistry is the more fundamental science. Chemistry, thermodynamics, and even biology, these are more fundamental than theoretical physics, than particle physics, because the particles depend upon these larger substances for their very being, on my view. So I'm going to give a couple reasons for thinking this. That's my claim, right? A couple reasons why I think this is a scientifically plausible view to hold. One has to do with algebraic quantum theory. And so I'm going to make a distinction here between the use of finitely composed Hilbert spaces, which Hans Primus calls pioneer quantum theory, and the infinite systems that are typically used in algebraic quantum theory. And I'm going to argue that that distinction is really important from a metaphysical point of view, from a philosophical point of view. So Hilbert space in the 30s and 40s, in quantum theory in the 30s and 40s, represented a system by means of a vector in a high dimensional space. So the space can have infinite many dimensions, but it doesn't have an infinite number of degrees of freedom, and it doesn't have an infinite number of subsystems on this picture. So each vector in this space represents a property of the system. It's called an observable. And these spaces represent systems with finitely many degrees of freedom. And all the observables are subject to Heisenberg's uncertainty principle. So you can't discover all of the properties simultaneously of one of these objects in this finite system. Now there's an important mathematical result called the Stone-von Neumann theorem. It was proven in 1931. And this shows that if you have this kind of a finite system, in a so-called separable system, then any two complete representations in it are equivalent. It's a relation called unitarily equivalence, which means that the vectors, all the vectors in that space represent the same macroscopic state. You can't make the distinctions that we want to make at a macroscopic level. And these separable systems are useless for chemistry and thermodynamics. They don't have what are called super selection sectors, which is what you need. And in particular, what you don't have is spontaneous symmetry breaking and phase transitions. Right? These are very important for chemistry, I'll explain in a minute, and for thermodynamics. In classical physics, you had spontaneous symmetry breaking, but in finite systems of quantum theory, you don't get it. And that's a result of the Stone-von Neumann theorem. No spontaneous symmetry breaking. So what quantum theorists in chemistry and thermodynamics do to get around the Stone-von Neumann theorem is to use infinite systems. They're called non-separable systems. And in those kinds of models, this theorem fails. And so these models have infinitely many degrees of freedom, and you have inequivalent representations, which are then used to represent macroscopic states like entropy, temperature, different phases of matter, things of that sort. So in order to get from a finite representation of the world to one of these infinite representations, what we do is go to the thermodynamic or continuum limit. So we treat the system as if it contained an infinite number of infinitesimally small molecules or other particles. And this actually fits the Aristotelian picture really well, because on Aristotle's view, this chemical substance really is a continuum of matter. It doesn't have discrete atoms and molecules in actuality. And so there are no internal discrete boundaries on this kind of picture, which fits, again, the Aristotelian picture very nicely. The individual atoms and molecules now exist only as virtual parts. They're not actually there in the new model, in this non-separable model. So there are three reasons for going to an infinite limit. One reason is just for mathematical convenience. It's easier in some cases to ignore some of the details. Sometimes you need it to isolate some factor from another. So in order to get rid of friction or something else, you might go to an infinite limit. But there's a third reason, that's to introduce new structure into the representation. And that's actually what's going on here in quantum theory when we go to these infinite non-separable systems. We're doing it because we need to do so in order to introduce new structure. And my claim is that when that happens, that shows that this new representation has ontological significance. It's actually telling us something about the world that we didn't have before. So again, here's the idea of spontaneous symmetry breaking. In a classical theory, right, if you put a perfectly symmetrical pencil on its end, it will eventually fall in one direction or another, right, thanks to tiny disturbances and so on. In finite separable quantum systems, what basically happens is the pencil falls in every direction at once, right? So there's no symmetry breaking, right? Everything could happen happens in a sense. And so you preserve the symmetry in that finite model. You don't have symmetry breaking occurring. But in order to have phase transitions, right, you have to have breaking of symmetry. For instance, so at the melting point or the boiling point, you can have solids and liquid that coexist, the same temperature and pressure, or liquid and gas that coexist, the same pressure and temperature. And it's just a kind of symmetry that's broken when it goes from one to the other, right? But that can't happen in these finite quantum models. You have to go to the thermodynamic limit or the continuum limit in order to get the spontaneous breaking. And that indicates that the finite model is missing something, right? These chemical substances they're more than the sum of their parts. That's the basic idea. They have properties that are not explainable in terms of the properties of their finitely many quantum particles. That's the thought. Okay, one last reason for going to something like an Aristotelian picture, and that's the need to have something like classical properties in the world. So here I'm building really on Niels Bohr, a great quantum theorist, who said that quantum theory does not exhaust reality, right? And this is really important because when you ask quantum theory, what are the fundamental properties of particles? The answer is, well, it's to have certain probabilities of being observed in different ways. But what does that mean, right? What does it mean to be observed? There's nothing in the quantum theory itself, there's nothing in the microphysical realm that tells you what an observation is or what a measurement is. And so what Bohr says, look, a measurement is when some quantum system interacts with a non-quantum system, a classical system. That's when you get measurement. And yet the quantum theory says the fundamental attributes of quantum particles are probabilities of reacting to non-quantum things in certain ways. Right? Well, by the very definition then of the quantum world can't be complete. It's inherently incomplete. And that points to the correctness of Aristotle's view that it's actually the composite substances that are fundamental, not the particles, right? Particles exist in this realm of potentiality. Heisenberg recognized this as well in his book on physics and philosophy, that really what quantum mechanics describes is a realm of potentiality, a realm of potential action on our classical objects in various ways. Now, the problem for Bohr was that he tries to divide the world into classical objects and quantum objects. And his way of doing it doesn't really work because there are obviously things like quantum computers and supercooled fluids that are both large scale macroscopic objects and also have quantum aspects to them. So the right way to think about this, I think, is to say that there are two kinds of properties, right? There are properties that are classical and there are properties that are quantum, right? The quantum properties are the ones which are non-commuting with each other, subject to Heisenberg uncertainty principle. The classical properties are the ones that are mutually commuting and that emerge in these infinite models. And it's the mark of a substance to have some classical properties and also perhaps some quantum properties, right? Quantum particles have only quantum properties. They don't have any classical properties at all. That's why they can't be substances. Substances have to have classical properties as well as quantum properties. That's the thought. So, so the persistence of chemical form itself is something that I don't have time to go into the details here, but basically, you know, we're taught in some cases in high school chemistry, right, that you stick these atoms together in a certain way, you get a molecule. So it's a kind of bottom-up explanation of what's going on chemically. It's just because the atoms and the electrons are in a certain place at a certain time, in certain relationship to each other, that you get these molecules. And that turns out just to be wrong. It turns out that the chemical form of chemical substance is something that has to be superimposed on the particles from the top down. So the particles act as if they're part of molecules because the substance has a certain chemical form, not vice versa. It's not water because there are water molecules. There are water molecules because there's water, right? That's the upshot, I think, of thinking about things in terms of quantum chemistry. So I'm going to skip over that. So chemical form of an inorganic substance really does exactly the things that Aristotle would want substantial form to do. And so, so chemical form, it grounds the classification of chemical substances into natural kinds. It grounds the persistence of a chemical substance over time, and it gives the substances active and passive power. So it does all the things that you'd expect a substantial form to do. Okay, I've got a few minutes left. I got this last section where I'm just going to talk about some implications of this for thinking about metaphysics now. How do we, some of the details, I guess, basically. So, so first of all, you remember I talked about the tiling constraint, where the idea was the world is basically made up of substances and their parts. That's the simple picture. But the problem is that there are some cases where there are parts with no substances anymore, right? So for instance, we could observe a photon from an extinct star. So the star's not there anymore, but we're still observing its photon, right? And on my view, the photon is just a part of the star. It's only a virtual part until it's observed. So how do you have these virtual parts floating around with no whole for them to be a part of? In the biological realm, we see this, right? You can keep a cell alive after the original organism is dead, right? And even produce daughter cells from that cells and whole cell lines that persist for long times past the death of the original organism. Spermatozoa and other sorts of things like that are clearly, you can, a sperm donor could have could father a child long after the father is dead, right? So how to explain that? And in Catholic theology, we have transubstantiation as well, where we've got parts of the bread and wine, in a sense, that persist even though the bread and wine are no longer there. And I think these are all exceptions, but not the rule. So the parts remain dependent on the whole in each of these cases, even when the whole doesn't exist. And so what we really should say as Aristotelians is the world is made up of substances, parts of substances, and in some cases, remnants of extinct substances, right? So there's really three things that are going on. But even those remnants are still, in a very important way, dependent on the substance of which they were originally a part, or the substance from which they originally came. So there's a sense in which the photon is still dependent in a way on the extinct star, even though the star is no longer there, for Aristotle. Sometimes people too ask me about, well, what happened at the Big Bang, or on your picture? I mean, what happens when you start out, there's only quantum particles in the world, right? And you're saying quantum particles aren't substances, and the world has to be made up of substances. So what was going on there? And my view is that at the Big Bang, we have one very small number of huge chemical substances, right? So even there, the quantum particles are still just potential parts or virtual parts of some very large substance. So on my picture, what happens after the Big Bang is not that you have a bunch of little things that sort of aggregate and clump together. You get one large substance that sort of breaks up into galaxy clusters and then galaxies and solar systems and so on. So it's a process of disaggregation rather than aggregation, I think, on this kind of a picture. So there are hard questions here, of course, about where does one chemical substance end and where does the next one begin, right? So I think bodies of water are typically chemical substances, but do I want to say there's just one chemical substance that fills all of the world's oceans? Or, is the Black Sea one substance, the Mediterranean Ocean another substance, or are there, eddies of water that are different substances even within the Black Sea and so on? I think these are hard questions. These are, for my mind, questions that are going to have to be answered by combining philosophy and empirical science in certain ways. The question is going to be, at what level do we get an entity that has its own unity and that has, because of that unity, its own thermal and chemical properties? What is the fundamental level? I think it's still a hard question on this picture, one that we're still sort of working on. So basically, I think that when you have two chemical substances, there should be some kind of sharp boundary between them, maybe a difference in temperature or chemical composition or something like that. A single substance should be characterized by some kind of collective causal power that substance has. And the integral and virtual parts should be wholly integrated into the substance in some ways, so that the substance is not reducible to its parts. Those are some of the criteria to look for as we're trying to evaluate things. So again, just to go back to original discussion, how is this all relevant to broader issues in philosophy? I think that once we accept that there's top-down formal determination of the parts by the whole, even in the inorganic world, right? Then it's not so surprising that that can happen in living organisms. That the soul, which is the form of the whole organism, can have top-down formal determination of the operation of its parts, or that the whole human being can have a kind of formal determination of, again, the activity of its parts. So the way this avoids dualism or the need for some kind of vital force is that we don't first establish a bunch of independently existing fundamental physical things, and then try to get some kind of soul to interact with it. We say rather that the very existence of the physical things depends on the soul. The soul is what's responsible for giving the physical things the physical natures they have and the relationships in space that they have. And so we don't need to have any kind of violations of physical law in order to have real top-down determination on this kind of picture. And so this gives us actually room, I think, for free will, even in a world in which there's no funny kind of interaction between the mind and the body. Here's a few articles that I've published on this recently. I've got a short book. It's called "Is St. Thomas's Aristotelian Philosophy of Nature Obsolete?" where a lot of my work's been put together recently, and some articles. And there's another book that William Simpson and Nicholas Tay and I published in 2017, where we put together a number of articles on these sorts of issues. So that's the whole shebang. And thanks so much for your attention. Let me go back and unshare. So
while he's working on that, Ennis was not able to make this. Evidently, his mother told him he couldn't go out and play.
Oh dear.
But Basel, al-Tai has graciously agreed to respond. And so I'm going to turn it over to Basel.
Yeah.
Great.
Hello. First of all, I should say that I am not a philosopher. I am a theoretical physicist specialized in quantum field theory and curved space-time, which means quantum fields and relativity theory. I've been working for about 40 years in this field, and what I have learned is that quantum mechanics is based on, or quantum theory, is based on basic pillars, bases, foundations, which are identified by the following: atomism, indeterminism, probabilistic nature of events, superposition of states. I really enjoyed listening to your talk, Rob, but I cannot see how can I mitigate what you have said with what I have learned. Aristotle, I don't know much about Aristotle, but I know for sure that he was against atomism. I know for sure that he was against indeterminism. I know for sure that he didn't realize the probabilistic nature of events or suggested such a possible description of the events in nature. Instead, he is deterministic, and he always believed in necessity, not contingency, while quantum mechanics specifies the states of any system as contingent. So what we have in quantum mechanics, opposite to what we have usually in classical mechanics. In classical mechanics, we have one well-defined state for the system, a particle, for example. But in quantum mechanics, we have many possible contingent, we call state, and this is usually obtained by solutions of the equation of motion of that system, whether it be relativistic or non-relativistic, whether it will be a solution of Dirac equation or Klein-Gordon equation or Schrodinger equation. Also, we believe that there are superposition is always possible because this is on the theoretical level. Superposition is one of the main principles of quantum mechanics, as you well know. Your presentation is new in I mean, to me, Sinu, perhaps to specialized people in your field is not, or philosopher, in presenting the chemical substances and the chemical compositions as some another form which obeys quantum mechanics partially, or what you have called also potential virtual states. Although I may, I mean, I found it something new to talk about virtual, to talk about particles like electron or proton or even photon as virtual states. They are not virtual because virtual states has a very well-defined status in our quantum physics, which is if you have the energy multiplied by the duration of existence of any object, including a human being, if you like, or a mountain, if the total energy multiplied by the time of or the duration of its existence is less than h bar, Planck constant, let us say, then it is virtual. Only then it is virtual. Otherwise, it is not virtual. An electron is not virtual. And also a proton, or these are fundamental objects which has a well-defined status, charge and spin, etc. Concerning the statistics and how the statistics is different, and actually you have two things. You have distinguishable and non-distinguishable particles. The Fermi-Dirac is identified, Fermi-Dirac statistic for spinners. All spinners, spin half rather, obey. But all non-spinners, or let us say integer spin, they follow the Bose-Einstein statistics, while half integer in general, 1/2, 3/2, 5/2, they all obey the Fermi-Dirac statistic, and this is concerned with the distinguishability and indistinguishability of the states. So it's really hard to understand how we can identify the components or the composition of even of a chemical, of molecules, chemical, as being virtual or as being classical. They are in a state, it depends on the size of molecule, actually. If you have a large molecule, very large molecule, composing of millions of atoms, say, then you can talk about a classical system or approximate it to a classical system. But in general, the limit between the macroscopic and microscopic is not well defined, as you perhaps agree with me in quantum mechanics. And this is one of the problems which we are fighting to define it. However, as I'm interested in philosophy and kalam, and as I have investigated during the last 25 or 30 years the philosophy of the kalam and mutakallimun, I found that the real representatives of quantum physics are the mutakallimun, not Aristotle. They are completely the opposite side, on the opposite side, the mutakallimun. And when I identify somebody to be, for example, now I am affiliated to the physics department at Leeds University. Before that, I was working in Jordan. When I moved to the UK, I applied for a visiting position at Leeds University. And they accepted me. Why? Because I am defined as a physicist. But if I go and apply to philosophy department, they may not accept me, because simply they will say, you are not trained like a philosopher. Although I've been working on kalam for a very long time. Reason is this: unless I prove myself as eligible to contribute to philosophy, they won't accept me as a visiting professor in philosophy. The reason is that I have no legacy in philosophy. I have a legacy in Kalam, and Kalam is different cup of tea, as they say. So when we say Aristotle is a quantum physicist or quantum physics vindicates Aristotle philosophy, we should have something solid in front of us. What we have, as far as I can see, that completely the other side. The mutakallimun could be vindicated. Why? Because they said atomism. They proposed the atomic nature of the world. Second, they proposed indeterminism, that the world is indeterminate. The events of the world are indeterministic. And they proposed what you may call the virtual state, which is recreation theory, that every property in nature, every object, you can say, so to speak, I mean, to put it in an approximate figure, every state is under continued recreation. And this recreation is discrete. By the way, even time, according to mutakallimun, is atomized, while time, according to Aristotle and most of the philosophers, Greek philosophers, is continuous, independent of the existence of system, etc. Now we are actually formalizing a theory of time within a quantum relativistic or quantum framework, and also to merge theory of relativity with quantum physics. Last June, I had my paper published in the first paper with Leeds University, colleagues from Leeds University. It is called Quantum Clocks and Time and Quantum Time. And it was a review about the last 10 years of work that they have been doing on this field. And we found that, again, time to be quantized, it means to be discrete, it atomized. And the result comes exactly, again, the final result comes in agreement with what Mutakallimun was talking about time, not from a philosophical point of view, but from a religious point of view. You know, they were talking about a sort of a block universe where past, present, and future are all there under the auspices of the divine. You know, it's recreating the world. The divine is sustaining the world through recreating every bit of it, every part, every smallest part in this world. But if I agree with you, when you talk about virtual, I mean, in the philosophical sense, when somebody says, what is psi? Can I catch psi in my hand? Or can I put it under microscope even? The answer is no. Yes, in this sense, psi is something virtual because it is an abstract mathematical object. Although psi is representing an electron or a proton or whatever, neutrino. But here we are, you know, it is, if you like to call it virtual, then it is virtual in this sense. Otherwise, it is not virtual because it is actually a mathematical expression that cannot be measured by itself. Psi square, as you well know, is the probability is proportional to the probability of finding the particle, etc. So with all respect, I would love to see something emerging from such studies that, I mean, which agrees with Aristotle, but it's I think it's very hard to achieve that. better to work on متكلمون, and perhaps you can join us also and with Mehmet Bulgin and to work on متكلمون, because I have already, my book will appear hopefully next month. It's called The Islamic Approach to Natural Philosophy, and then subtitle Principles of Daqiq al-Kalam. Now it is in the press. Today I was doing some work to correct or proofing, make proofs, etc. It will be published in the United Kingdom. And here there is a really fruitful work that can be done, including understanding the vacuum, etc., quantum vacuum, and etc. And perhaps we can suggest some solutions to the problem of measurement in quantum mechanics through the Kalam arguments. I will stop here. Perhaps I have taken even more than 15 minutes, Mohammed. I'm not Kelly.
You were good, Basel. You were good.
Yeah. Thank you.
And I think
I'm pleased to have such an occasion, Kelly. Really, it's something really appreciable. Yeah.
Rob, I think he gave you a lot to talk about. So, and you don't have to talk about everything. You can do what you want there, and then we'll open it up to the group.
Well, I would actually be interested more about this quantizing of time, because in a certain sense, Aristotle does think that time is discrete, but he just thinks it's infinitely divisible. And so if it turned out that there were minimal units of time that couldn't be divided, that would be a problem for Aristotle. But I don't think that's in fact the view that is emerging from quantum gravity theories, as I understand them. So, and more generally, I think we probably should have a much longer conversation about how to understand Aristotle and the Aristotelian tradition vis-a-vis the Kalam tradition. Again, there's a sense in which Aristotle also is compatible with and believed in a kind of atomism. He thought that the natural world was atomistically organized in some respects. But the difference is that he thought that wholes, right, are typically more fundamental than their parts, including their atomic parts. And that was the thing I was really pushing, that I think quantum theory does give us a kind of holism that's really undeniable, I think, in the end. And because of entanglement and all of that. And so that's an important thing. Another thing about indeterminism too, I think Aristotle actually does have an indeterministic universe. It's just that the paradigm case for indeterminism for him is human choice, human free will. I think it could be easily extended to allow indeterminism in the natural world. Admittedly, Aristotle doesn't do that, but it wouldn't be a major change. There's another big problem, of course, when you do the kind of work I'm doing, is obviously I can't claim that everything Aristotle thought was right, because obviously most of it was wrong. But the question is there a kind of fundamental core to his theory, right, that would help us understand the quantum world? And I think there is, actually, once you peel away some of the bits that are not adequate. We're actually working right now with a lot of physicists on this kind of project, particularly physicists who are interested in things like chemistry and thermodynamics and solid state, condensed state matter physics, because that's really where you see this holism playing out, and where Aristotle is actually most relevant, as opposed to purely theoretical kinds of physics where you're not worrying about these kinds of composite objects and their interactions. So maybe I'll leave it there.
Yeah, thank you. Thank you.
Hey, so Rob, this just occurs to me. I do have a question concerning parts and wholes. Does this kind of you're doing this with physicists, and it just occurred to me, does it make different predictions than a more anti-Aristotelian ontology physics? I'm not quite sure what to call the other option, but anyway.
I mean, in a sense it does, because if you applied quantum theory to chemistry and thermodynamics in a kind of naive way, you would have to say there's no such thing as a distinction between solids and liquids, for instance. And there are actually some physicists who say that. Who say because quantum theory, because of the Stone-von Neumann theorem says there can't be spontaneous symmetry breaking, there can't be different phases of matter. It's an illusion. So I think that's in a way a refutation of that view, but of course they can say, well, actually there aren't, you think there are solids and liquids, but you're wrong, right? So as in many things, even in the sciences, it sometimes turns out to be controversial whether what the data say.
All right, I'm going to open the floor up for questions. While if people wouldn't mind writing them in the chat. If you have a question, write it in the chat, then we can see it and I can call on you in the chat.
Yeah.
I had one question about, like, are kidneys and livers substances?
No.
I'm asking a question about parts of humans and then the whole of humans. You were at a more micro level, I think, in a lot of what you talked about.
Right. Yeah. So the organic parts, going down to cells and organelles in cells and so on, those would all be integral parts in my picture. Yeah. So those are actually there. They're not substances because they're definitionally dependent on the whole organism. If I ask, what is this thing? The answer is, it's a human red blood cell, right? It's a cell whose purpose is to contribute to the human organism in a certain way.
So it's relativized to the whole that it's a part of.
It's very being. Its very definition as a thing is relative.
Okay. Mm-hmm. All right. Okay, good. Yeah, I wondered what you would say to that. Your other examples. I thought you might say something like that. I have no refutation of it. I found this whole thing really interesting and counterintuitive to the sort of the micro particleism that we constantly are force fed. We don't get another view. You're running, but it does seem like another view needs to be on the table. Like we think there are tables and chairs, and not just particles arranged table and chair. Well, I don't know what you say about tables and chairs, but
I mean, tables and chairs aren't substances, but they're made up of macroscopic substances, right? Yeah. Chunks of wood or substances, probably. Yeah.
All right. I don't see anyone else.
Got a question, I think.
Is there a hand up? I don't see all the hands. So, Mehmet.
Yeah, thank you very much. I appreciate, I very benefited, Robert and Basel. Thank you again. So I was thinking to ask two questions, by the way, but partially Dr. Basel mentioned them. And maybe, Rob, you can add something more. My first question was about, there was a conflict between general theory of relativity and quantum physics, The first one is based on continuity, and quantum physics introduced discontinuity, and then physicists, they try to reconcile them. And then it turns out quantum gravity. So how would Aristotle solve that problem? The first one was that. The second one, you already mentioned a little bit, maybe you can add one little bit more. Quantum physics has raised some weird issues. Seemingly, it violates Aristotelian logics, such as superpositions, also unlocality, indeterminism. Even quantum physics interprets causality differently. Does quantum physics treat Aristotelian logics? So maybe I can add singularities, general theory of relativity introduced singularity, and it seems that actual infinity exists in some extent. Does it violate Aristotelian premise that actual infinity cannot exist? Thank you again, Rob.
Yeah, great. Those are really good questions. Thanks for giving me a chance to respond, because I didn't get a chance to come back on those two things. Yeah, so let's see. Trying to remember what the first point was. Oh, right, general relativity and quantum mechanics. So, so Aristotle's approach to the sciences is a kind of pluralistic approach. That is, he thinks you're going to have a science of biology, and even more specifically, a science of zoology, and another science of chemistry, and so on. And with the scientific revolution, the 17th century, there was this idea that there would be a single unified science of everything, right? And that goes in hand with the microphysicalism that I was criticizing, right? Because if the fundamental reality is just this microphysical reality, then you just come up with a single theory for that, you've solved everything, right? And the Aristotelian approach is going to be to say, no, look, quantum theory is a perfectly good theory for how substances interact with each other via these really small particles. But it's not a good theory about the large scale, phenomena in astronomy, right? For that, you need general theory of relativity. And if you can't put all those together into one grand theory, Aristotle say, fine. Who says he should? I mean, there are different things with different natures that raise different questions. And so Aristotle's approach, I think, again, this is another area where Aristotle's actually ahead of the game here, right? He's saying, look, let's not worry about trying to create a single theory of everything. And then the last point you make about superposition, I did want to say something about this. I mean, Aristotle has superposition, and this is exactly what Heisenberg recognizes in his book on physics and philosophy, because superposition, on my perspective, is just potentiality, right? So things have potentials to be various things, including contradictory things, right? The rock has the potential to be hotter and colder. Hot and cold are contradictory. It can have both potentialities at once. That's part of Aristotle's story, right? And what happens in what quantum theory is describing is, as Heisenberg recognizes, is this fluctuating space of potentialities, right? Where probability weight is growing or shrinking with respect to various potentialities. But these potentialities have to become actual at some point, right? And that's where we get into the measurement problem, right? And so I didn't really have a chance to talk about that in much depth, but I think all the non-Aristotelian microphysicalist approaches to quantum mechanics crash into the measurement problem. They can't solve it, right? And I think Aristotle's view is the only one that can, because Aristotle's view says, look, the quantum world is not complete. He's with Bohr on this. He and Bohr are on one side, everybody else is on the other side, right? There's a non-quantum world out there, right? A world of wholes that are not totally determined in a bottom-up way. And it's when quantum systems interact with those non-quantum substances that you get measurements, right? So you don't need a human mind. You don't even need a living organism. You just need a non-quantum substance, right? With its own chemical and thermodynamical properties, right? Interacting with these quantum states in various ways. If you don't do that, you end up with something crazy like many worlds theories or Bohmian theories or other kind of extreme speculations like GRW theory and so on. Aristotle is one way to avoid that. Now, on the point about causation too, again, I think rightly understood, Aristotle has got this right, which is that causation always involves two things, an agent and a patient. And the agent is actualizing some potential in the patient. And that's exactly what happens in every quantum measurement. There's an agent, which is the observer, the measurement instrument. It's actualizing some potential of the quantum system. And so in fact, that's exactly the sort of thing that Aristotle is describing.
All right, you happy with that, Mehmet?
Yeah. This is the first pass.
Enough. Thank you.
Yeah. A lot to think about. Mustafa, you have a question. Mustafa Steyer?
Yes, thank you. I just returned.
Mustafa, would it be possible to put your
yeah, I was just going to comment on that. I've just returned from a semi-major bone grafting surgery to put teeth in and things. So
nice. Okay, yeah, safe.
And I literally have an ice pack on and everything. So I missed Professor Koons in Cambridge last year and really wanted to attend. And I saw this. Unfortunately, it was booked on the same date as the only time I could book the surgery before traveling. So I did miss a lot of what preceded. It's a very important topic for me. I also, speaking from the point of view of Kanam and trying to make it a living tradition, which, you know, A, shows it's viable, B, shows its relationship to the modern world and is responsible to science, I get concerned when I hear people speak about Kanam in a way that may not entirely represent the rich history. You know, the post-Ghazalian and post-Avicennan Kanam is very much a realist metaphysics, because we have to say that things have quiddities, whether those are accidents or substances, in order to have a in order to have a natural theology which builds up from what's known towards what is not known. So there's an incredibly important text which is spread everywhere, which is, it's called Sharh al-Aqaid, right? Which just means the Taftazani's commentary on a work by Nasafi. Everyone knows it, and really it replaced a lot of the other texts in the advanced seminaries. So it's you know, its position cannot be denied in the late tradition. And I see a lot of people that are signed in, you know, from Turkey, and you know, that's where the Ottoman Empire obviously was, and these texts were well rooted there. So I think two things have to be stated regarding early Kalam. One is that they do maintain the atomistic substrate, but I have to say also their atoms cannot be made to match up with contemporary atom theory. I think that's probably obvious to some people, but it has to be stated, because otherwise there's so much unclarity in even getting started with the principles of this conversation that we're not really going to get anywhere. So what they do is they say, you know, okay, we have these substances, but they have this atomic substrate, but they still have an essential nature. And in fact, after a very important scholar named Dewani, pretty much all of the Indian and Ottoman, which were where the kind of impetus of the growing scholarship was. In other words, they were kind of the leaders in the historical period that we call like the gunpowder empires. They globally, that, you know, that term kind of applies. But the point is that they had a shared ontology where, yes, we have these kind of atoms at a microscopic level, but at a macroscopic level, we have knowable substances that have realities. And after Dewani, they actually say that they have intelligible quiddities. I mean, what I know from Aristotle is that he says, you know, we need the active intellect because the form and the substance are only they're active or actual in terms of sense realities, but they're only potentially intelligible. So these guys following Avicenna, who's slightly Platonist, but still mostly Aristotelian, would say no. They'd say you know, for Zaid to exist as a human being, the quiddity has to exist. Now, they're not going to deny that time is, well, let's leave time aside. They're not going to deny that matter is discrete, but it's still the way it appears to us in the world is active. And so I think you know, any people that are working in Islamic theology really need to get these basics clear, otherwise the dialogue's going backwards. And then also people who are coming from the other side and want to engage with Muslim philosophers need to engage with those people who've kind of already figured these things out. That's not so much of a question. I mean, this is an area that I was headed into in future research. I spent 7 years working on definition in late Kalam, and you know, whether they uphold demonstrative science and all that type of thing. And I had to do a lot of clearing out of misunderstandings. I know I didn't.
So Mustafa, is this more aimed at Basel than Rob?
No, well, yeah, no, I'd love.
Sure. It's not a question, and there's not an answerer here, but
yeah, Rob, I want to ask you a question first. Do you know Brian Kimple with the Lyceum Institute, who has the Realism journal?
Yeah, I know of him. I haven't met him, but I know a little about him.
Okay. Well, you know, I've studied with him, and I think if one is looking at the late Kalam position, that, you know, everything that one would need. You know, I just get concerned with the way that Gödel's theorem or whatever it is, we railroad common sense out of the equation so easily because of the zeitgeist that we live in. And, you know, that the realism is firmly rooted in late Kalam. You know, I'm not speaking of the early Kalam. The only thing I'll say about the early Kalam, and this is Dr. Basel's area, but when Asheris speak about substances, well, if they say Kalam atoms are substances and they say that they're all identical, the later guys will say, we appreciate your theological principles that have made you choose this doctrine, but if it's taken literally, it leads to sophistry. I mean, that's the word they use, safsata, which basically in the paper that I have submitted, I equate it with skepticism regarding, you know, quantitative realities. And
so
yeah.
ask question real quick.
We probably ought to just move into a response by Rob, or maybe.
Yeah. Well, I have a question response really, which is are you suggesting, and I hope this is true, that the later Kalam is in moving towards quiddities, in a way is also moving towards the possibility of what I call the top-down or formal determination of the atoms by larger objects, so to speak, as opposed to, I mean, I think that oftentimes one thinks, I think myself, oh, Kalam, they're going to be really happy with microphysicalism because they think everything's atomic and the atoms are in charge, right? And you're maybe suggesting that in later Kalam, there's more room for other things to be determining the atoms in a top-down kind of way. Is that plausible?
Absolutely. You know, if we would say that things are merely reducible to their atoms or whatever, in the late tradition, and when I say the late tradition, I mean Ghazali and those that came after him, that I can't help but mention just very quickly without hogging the mic here, but there's a historical amnesia that occurred in our tradition. So we're kind of rediscovering the latest tradition. Why did everyone who kind of studied Kalam go back to Ghazali and earlier versions? That's a very big question, and it doesn't make sense because you know you have a living tradition. But the problem is that those living traditions were they were kind of snuffed out, so they don't really exist except for in little backwaters like Kurdish Iraq and that type of thing. Or, of course, in the madrasa, again, the Kurdish madrasas in Turkey also have it to a certain degree, but they don't teach the advanced Kalam manuals. You can't find anywhere the metaphysical ones that go into what we call the Umur Amma. It's basically the metaphysical properties that pertain to a thing because of its existence. You know, the quiddity, causality, that type of thing. Yeah. So there's a difficulty in just the Kalam representing itself right now accurately as a late, but the late position definitely. I don't want to hog the mic here, so let me hand over.
Yeah, well, that's really interesting. I'd like to learn more about that, all of that, actually. It sounds like, in a way, there's a common phenomenon in both Christian and Islamic worlds that during the modern era, an awful lot of valuable knowledge was lost, basically. Yeah. You know, a lot of baby thrown out with the bathwater, as we put it.
Yes, I think so.
I hope I can have the chance to say something.
Basel, why don't you go ahead?
I want to say something about the late Kalam, the early Kalam. From my investigation, it was clear to me that the late Kalam was mixed with philosophical methodology and argumentation. The late Kalam, after al-Razi, al-Fakhr al-Razi. And there were many, I would say, non-original themes inserted or intervened into the Kalam proposition and discussions. This is number one. The early kalam I find is more pure, is more internal product of those people which were called mutakallimun, whether in Basra or in Baghdad. Second, there is, and this is very, very important point, there is a sort of confusion in presenting the terms, even with the very serious names and researchers like Harry Wolfson and Shlomo Pines or Pines concerning the definitions. For example, they don't differentiate between Jawhar and atom, and they say, and also Dhannani, Nur Dhannani, in his book, the Kalam, Physics of Basriyan, etc. They mix between the term atom and the Jawhar. Jawhar is not atom. The Jawhar plus the Arab makes the indivisible part, which you may call atom if you like, because if you go deeply into the definition of Jawhar, according to Jurjani, for example, the early mutakallimun, they meant to say that the Jawhar is the essence, and this essence is a sort of an abstract entity or describing, if you like, call it then, Rob, a virtual state. It's describing a psi, actually, which you cannot measure because they already say the Jawhar has no meaning. It can't stand alone. It's not the substance of Aristotle or the Greek philosophy. The mix and the confusion made when we thought that the Jawhar is a substance and the Arad is accident. This is how they translate it, which is wrong. Arad is not accident. Arad is a transient entity, which if associated with the Jawhar, they can make the indivisible part. And this is the main difference between the Greek atom and the Islamic atom. The Islamic atom is two components, Jawhar and Arad. The Greek atom is a lump sum, is an infinitesimal point, or it's finite in size, and it has a magnitude. That's what made Harry Wolfson, in great confusion when he says, I cannot understand, in his book, The Philosophy of the Kalam, I cannot understand how these people could imagine something magnitudeless. The Islamic atom, in his view, is magnitudeless because he thought the Jawhar is the atom. Jawhar is not the atom. The Jawhar has to get something, including occupancy is the main feature for the Jawhar. So if the Jawhar gets Arad and gets occupancy, that is atom, could be. And this is the problem. That's why in my book, if Mustafa reads Arabic, he can already read this book, which is Daqiq al-Kalam in Arabic. And otherwise, in 2 months' time, perhaps he can read the English version, which will appear, I hope, soon. Here, in about 3-4 pages, I discuss these terms and identify what are the mistakes were made by serious researchers even. Thank you.
That's probably, I don't know if you want to comment, Rob, or get a couple more people in. This is.
Yeah, I just want to say that it's interesting. I'd like to learn more about that because it sounds to me like there's a kind of form matter duality then in that version of Kalam that maybe.
Yeah, exactly. Exactly.
Aristotle,
Rob, simply, the principle of recreation, which is well known, at least in Ash'arite Kalam, although it is already adopted by Mu'tazili, but some people do not know that the Mu'tazili adopted the same principles of the natural philosophy. I mean, the natural kalam, the kalam about natural world. They adopted the same principles, including indeterminism, including their position on causality. Qadi Abd al-Jabbar, well-known Mu'tazili, he is echoing what in his book, Muhit bil-Taklif, he is echoing what Baqillani, the Ash'arite, have said, including he gives the same examples about the causality and what is causal indeterminism. Many people say Mutakallimun or Ash'arite do not believe in causality. Wrong again. They believe in causality, but they don't believe in deterministic causality. They acknowledge causal relationships for sure, including Al-Ghazali. And now you mentioned entanglement. What's entanglement? It's iqtiran. Entanglement, two items are entangled, iqtiran. And this comes in the modern concept of quantum causality. So causal relation exists, but causal determinism do not exist for the mutakallimun, Ash'arite or Mu'tazilite. Some of the Mu'tazilite, like the Baghdadi Mu'tazilite, they didn't acknowledge this causal indeterminism. They didn't acknowledge that. They said the causal effect should be deterministic. Al-Ka'bi, for example, their sheikh, their leader, one of their leaders. But the Basriyan and most of the Mutakallimun, including obviously all the Ash'arites.
Hey, Kelly, maybe we can get one more question. I've got to go to class here myself. And then
let's take Sumaya and then we'll close.
Okay, sounds good.
Sorry, Ibrahim. We're just going to take one more.
Yeah.
Sumaya?
Hello.
Hi.
Thank you for the presentation and also for the response. My question is if it's possible for you to point out what would be the position of Aristotle about the Big Bang theory, since the theory says that space and time has a beginning.
What was his position about what exactly? B theory, what you said?
Big Bang theory.
Big Bang theory. Oh, right, yeah. Yeah, good. So it's right that Aristotle seems to have thought that time did not have a beginning. I think there's some question here as to how deeply committed he was to that, actually. I mean, it seems pretty clear that he's saying that for every instant, every moment in time, there's an earlier moment. That's actually compatible with the Big Bang, in fact, because you don't need to have it a first moment in the Big Bang. You could approach closer and closer to t = 0 without ever actually getting there. So again, I think this is a good example, really, of the importance of distinguishing between the fundamental, the primary elements of Aristotle's system, the secondary elements, the tertiary elements, right? I mean, he clearly believed that there were solid crystalline spheres rotating around the Earth, right? He was wrong about that, no question, right? But how fundamental is that to his philosophy? Not very at all, I think, even in his own mind, right? That was the best he could do given the limited empirical data he had. But it wasn't part of his metaphysical theory as such, right? And so likewise, the idea that he thought the world was a steady state universe, always been more or less the same, he was wrong, but it wasn't a deep commitment of his. It was just, it was a perfectly reasonable belief at the time. But it was a tertiary or at best a secondary part of his system.
Right.
Yeah, may I add, Rob, that
Basel, Rob's got to go to class, so I think we should take that as the end and thank Rob for his contribution. Basel, thank you too.
Yeah, thanks very much.
All of you participants, thanks for coming. Glad you could be part of it. Let's give
Rob
a hand.
Real privilege.
All right, I'll give Rob a hand. There we go.
Thank you very much.
All right. Thanks, everybody.
Hope to see y'all soon.
Thank you, Kelly. Bye-bye.
Good to see you. Bye, Mehmet.